There's a reason why some software feels impossible to maintain. A tiny update breaks 5 other features. Now, here's the weird part. Fixing one bug creates 3 new ones. And after a few months, nobody on the team even wants to touch the code anymore. Some of the largest systems on the earth, video games, baking apps, flight systems, even parts of AI infrastructure, avoid this chaos using an idea that was invented over 50 years ago. An idea inspired by objects, not futurist objects, not mathematical abstractions, regular everyday things. Cars, dogs, buttons, accounts, people, and somehow that become one of the most important concepts in programming history, object-oriented programming, or OOP. And today we're going to understand why programmers become obsessed with it. I'm Yukari Esther, and this is NeuroBloom, where we make complex technology actually understandable. So, if that sounds interesting to you, consider subscribing and leaving a like. It really helps the channel grow. And if you'd like to directly support future videos, you can also support me on Buy Me a Coffee. So, with that said, let's dive into it. Back in the early days of programming, developers mostly wrote code like a giant instruction manual. Step 1, Step 2, Step 3, simple enough. But as software grew larger, things became messy very quickly, because real life isn't organized as one gigantic checklist. Think about a city. You don't run a city using one massive document that controls every single human action individually. Instead, the world is made of independent entities. Cars have behaviors, people have roles, traffic lights have states, banks manage accounts. Everything contains its own information and its own actions, and eventually programmers realized, wait, maybe software should work the same way. That idea became object-oriented programming. At its core, OOP is basically a way of organizing code around objects. And an object is simply something that contains data and behavior. For example, a dog object might contain name, age, breed, and behavior like bark, sleep, run. So instead of scattering information everywhere in the code, everything related to dog stays together, which is honestly how humans naturally think about things. Nobody say activate biological sound function number 3. We say the dog barked. That's object thinking. Now, here's where things get interesting. Programmers didn't just create individual objects manually forever, because that would be exhausting. Instead, they created blueprints. These blueprints are called classes. A class is like the design for an object. Think of it like a cookie cutter. The cutter itself is the class. The cookies are the objects. One blueprint, many instances. So if the game has 1,000 enemies, you don't code every enemy separately. You create one enemy class, and from that blueprint, the game generates hundreds of enemy objects automatically. That's why OOP became revolutionary. It allowed programmers to scale software without losing their sanity, which historically programmers are very good at losing. Now, let's talk about one of the most misunderstood concepts in OOP, encapsulation, which sounds less like programming and more like a medical condition. But the idea is actually simple. Encapsulation means an object protects its internal data and controls how other parts of the program interact with it. For example, think about a vending machine. You press the button, insert money, receive snacks. Simple. But internally, that machine is managing motors, sensors, calculations, inventory systems, maybe even temperature control. You don't need to know any of that. And honestly, you probably shouldn't. Because if anyone could directly manipulate the internals, chaos would happen immediately. Someone would set the price of chips to -$3 and bankrupt the machine in few minutes. Encapsulation prevents that. Objects expose only what's necessary. Everything else they protect. Then comes inheritance. And this is where OP starts looking almost biological. Suppose you create a vehicle class. Every vehicle might have speed, petrol, start engine. Makes sense. Now you create a car class. Do you rewrite all that code again? No. The car inherits those features from vehicle. Then maybe motorcycle also inherits from vehicle. This saves massive amounts of duplicated code, but more importantly, it mirrors how humans categorize reality. A car is a vehicle. A motorcycle is a vehicle, but car is not a motorcycle. OP works because it models relationships in ways our brains already understand. That's one reason it becomes so popular. And then there's polymorphism, which sounds terrifying, but it's surprisingly elegant. Polymorphism basically means different objects can respond to the same action in different ways. For example, a dog object might make a barking sound. A car object might meow. A bird object might chirp. But they all respond to the same command, make sound. Same interface, different behavior. And this turns out to be incredibly powerful for software design, because programmers can write flexible systems without hard coding every possible situation, which becomes essential once software grows enormous, and modern software is enormous. Some applications contain millions of lines of code. That's enough text to rival entire libraries. Fun fact, the first widely recognized OOP language was called Simula, created in the 1960s, and it was originally designed for simulations. Not websites, not apps, not games, simulations. Because researchers needed a way to represent real-world entities interacting with each other, which is exactly what OP does. And decades later, the same core ideas are still powering modern languages like Python, Java, C++, and C#. That's an unusually long lifespan in technology, especially in an industry where people rewrite everything every 6 months because a framework added rounded buttons. Now, is OP perfect? Not even close. Some developers argue it become overused. Others prefer functional programming for certain problems. And honestly, modern software often mix multiple programming styles together. But OP changed how humans think about software engineering forever. Because before OP, programs were mostly sequence of instructions. After OP, programs became system of interacting entities, tiny digital worlds. And once you notice that idea, you start seeing it everywhere. Games, apps, operation systems, AI tools. objects interacting with objects. So let's recap. Object-oriented programming organizes software around objects, and objects contain data and behaviors. Classes act as blueprints for creating objects. Encapsulations protect internal complexity. Inheritance allows objects to reuse shared features, and polymorphism lets different objects respond uniquely to the same action. All of this helps developers build software that's more organized, reusable, scalable, and easier to maintain, which is incredibly important once projects became massive. And that's why OOP became one of the foundations of modern programming. If this video helped make OOP finally click for you, hit the like button and subscribe to NeuroBloom for more deep dives into technology, AI, and computer science concepts explained in a way that actually makes sense. And if there's another tech topic you want explored next, leave it down in the comments. Thanks for watching. See you in the next one. Bye!